Another way to solve systems of equations is by using substitution. In the substitution method, you set both equations equal to a variable, or one of them equal to a variable, then you substitute it in and solve for the variable. So in this one it says, Alejandro has a computer support business. He estimates that the cost to run his business can be represented by y equals 48x plus 500, where x is the number of customers. He also estimates that his income can be represented by y equals 65x minus 145. How many customers will Alejandro need to order in order to break even? What will his profit be if he has 60 customers? So essentially what it says is, here's one equation, y equals 48x plus 500. That equation represents how much he gets paid. Then the next one, or his income in this one, is y equals 65x minus 145. So all he has to do, or what we want to do to break even, is so that the amount he makes is equal to the amount that it costs to run his business. So what we can do is, you'll notice that this one is equal to the variable y, and this one is equal to the variable y. So if they're both equal to the same thing, they can be equal to each other. So we'll set it up like that. 48x plus 500 is equal to 65x minus 145. And now this becomes a more on top of it. Well, we see that the right has more x's on it, so we subtract 48x from both sides. And we see that 500 is equal to 17x minus 145. I add 145 to both sides so that all the x's are on one side, all the numbers are on the other. And I find that 645 is equal to 17x. So to get x by itself, divide both sides by 17. And I find that x is equal to 37.9, approximately. So what exactly is 37.9? Well, that is how many customers he'll need to break even. So obviously you can have 9/10 of a customer, so we could probably round that up to about 38 customers. So he has to have 38 customers in order to break even on the cost. Okay? Now, the real question is, what will be his profit if he has 60 customers? So we have to figure out which one of those equations works to figure out his profit. Well, what we're going to do then is we're going to take it and we're going to put that into the second equation right here. We're going to put 60 customers in for x. And so we say 65 times 60 minus 145. Put that in our calculator, and we'll see it to be $375. So his profit on 60 customers is $375. Here's a couple guided practice problems you can try. They're not word problems, but you can set them up very similarly. Solve for one variable, set them equal to each other, and then we can do it. Another method of solving systems equations is the elimination method. So elimination is you make sure that one of your variables, one of the coefficients, is the exact same. And then you can add or subtract down to eliminate one of them, solve it for the one variable, plug it back in to find the other. So we'll see one right here. So if I look at this one right here, 5x plus 3y equals negative 19, and 8x plus 3y equals negative 25, what I can do is I can either add or subtract down to get rid of one of the variables. Now you'll notice that both of them have a 3y in them, a positive 3y. So I'm going to subtract down, like we used to do in adding and subtracting in elementary school. So 5x minus 8x is negative 3x. 3y minus 3y goes away. And negative 19 minus a negative 25 ends up being 6. Because negative 19 minus a negative is like adding. Negative 19 plus 25 is 6. So now, divide both sides by negative 3, and you see that x is equal to negative 2. So that works well for us. So what we want to do next is find what y is, since this is going to be an ordered pairs of solution. So I'll take the first equation, and you can pick either one, but I'll take the top one. And I'll do 5 times negative 2, because I'm taking this and plugging them in for x, plus 3y is equal to negative 19. So negative 10 plus 3y is equal to negative 19. Well, all the y's are on the left, so I'm going to make sure all the numbers are on the right. I add 10 to both sides, and I find that 3y is equal to negative 19. Negative 9. Divide both sides by 3, and we find that y is equal to negative 3. So the solution to my system is actually the point negative 2, negative 3. Remember, our solutions generally are ordered pairs, an x and a y. Here's a couple of guided practice problems you can also try. Now, if I look at this one right here, okay, it says solve the system of equations. 5x plus 3y equals 52, and 15x plus 3y equals 54. Now, the thing I notice about this is neither of the coefficients in front of x are the same, and neither of them in the y are the same. So what I'm going to do is I'm going to multiply either one or both of the equations so that they are. Now, the easiest one is I can see that the top, if I multiply it by 3, I now have 15x. So I'd have 15x plus 9y is equal to 156. The bottom is 15x plus 9y equals 54. And so to eliminate one of the x's, I would subtract down. That end up with 0. But the problem is now I have 9y minus 9y is also 0, and so it's equal to 102. So 0 plus 0 equals 102 is not true. So this is actually no solution. So we can have times where it's no solution, and that's when you add and subtract down, and both equations are eliminated. Here's a couple guided practice problems that you can try as well. So essentially it goes like this. Okay, here are the different ways to solve the systems of equations. One way is through a table, and that's the best way to estimate a solution if you're not exactly sure. Graphing will always give you one, but it's normally really hard when you have fractions or decimals. Substitution works really nice if they're both solved out for the same variable. You can use elimination using adding or subtracting. Those both work pretty nice. And finally, the last one, multiplication. If neither one of the coefficients is the same, multiply or divide one of the top or bottom ones so that they are.